Hi everyone. So one of the most common questions I get from new astronomers is what kind of eyepiece to buy for their new telescope. So since I have a couple of eyepieces and a couple of telescopes, I decided I would do a review of all of my eyepieces. So this is the telescope that I decided to use. This is my Orion 8-inch f3.9 reflector telescope. This used to be my imaging scope, but I've since started using it as my main visual scope because I'm using the C11 Edge as my imaging scope now. And it has a coma corrector in here as well, so it gives nice sharp stars all the way across the field of view. So for that reason, I thought it would be the perfect telescope to review all of my eyepieces. So whatever aberrations are present in the eyepiece, they're not affected by the telescope itself because the scope gives you a nice flat field with pinpoint stars all the way across. So let's get started. Hey guys, Abdur here. So today I'm going to be reviewing all of my eyepieces, but first let's quickly switch over to PowerPoint, to a little presentation that I've made just to go over some basics of eyepieces for anyone who might be joining us for the first time or who might be new to astronomy. So when you're looking to buy an eyepiece or trying to find out what the best eyepiece might be for you, the first consideration is going to be what magnification that particular eyepiece is going to give you in your telescope. So for that, you need to know what the focal length of your telescope is. So you can find that information quite easily on the manufacturer's website. So for example, if you have an 8-inch Dobsonian telescope, which is a very common telescope, you'd go to Skywatcher's website, and right here under the classic 200p, you would take a look to see what the focal length is. And the focal length of that telescope is 1200 millimeters. And in the 10-inch, it's also 1200 millimeters, and the 6-inch is also 1200 millimeters. Just that their focal ratio is different because the larger scopes have larger mirrors. So what you need is just this value, the focal length. And once you have that, what you can do is figure out the magnification that any eyepiece is going to give you in that particular telescope. So for example, the eyepiece that I mainly use for my wide field views, this guy over here, the Lunt Engineering HDC 20mm 100 degree eyepiece. This eyepiece in my telescope, which has a focal length of 800 millimeters, will give me 40 times magnification. So to figure out the magnification, I'll just divide the focal length of the telescope, in my case 800 millimeters. In the case of the 8-inch Dobsonian that we were looking at previously, that would be 1200 millimeters divided by 20 millimeters. So in my telescope, this eyepiece gives you 40 times magnification, whereas in a telescope with a 1200 millimeter focal length, it would give you 60 times magnification, which is quite good for wide field views. So up next, the next thing we look at is the field of view of an eyepiece. So a basic Plossl, for example, will give you about a 50-degree field of view. So that's what you're looking at in the first picture here, and after that you get 68-degree or 70-degree field of view eyepieces. We'll be looking at some of those, and then you have really wide field eyepieces like the 82-degree Celestron Luminos or any of them like that, and then some eyepieces like the TeleVue Ethos series or this Lunt Engineering 20mm 100-degree eyepiece. They have 100-degree or larger field of view, so you can get eyepieces in multiple fields of view, and of course the ones with the larger field of view are going to be more expensive generally. And so what's the best magnification to use for your telescope? That's a very common question that I get from beginners all the time. The important considerations are as follows. First, you want to match your magnification to the seeing conditions. So if you live close to the mountains like I do, for example, you rarely will get good seeing. So if you're trying to view something at 400 times magnification, the nights where the seeing is good enough to do that are going to be very, very rare. Most of the time you'll be using your more wide angle eyepieces like a 20 or 30 millimeter eyepiece. So you have to match your magnification to your seeing condition. If the seeing conditions are really good, you can use higher magnification. Otherwise, you'll largely stick to wide field or medium magnification eyepieces. And the more you magnify a view, the darker it gets. So if you have a small telescope, you likely don't want to use eyepieces that provide very high magnification, because the view will get darker as you magnify more and more. If you have a larger telescope, it can usually take more magnification before the view gets too dark. So an 8-inch Dobsonian, for example, the maximum useful magnification is about 400 times in that, and you can get that information from the manufacturer's website as well. Whereas for a small 80mm refractor, most of the time I stick to between about 100 times and 200 times with that. You can push it on planets and bright objects sometimes, but the view still gets darker in smaller scopes, I find. And in my large 16-inch Dobsonian, I mean, I use 600-700 times often enough whenever the seeing permits. So as a general rule, a bigger scope allows you to use more magnification. And some of the things that I compare in eyepieces when I'm trying out a new eyepiece are as follows. First, I look for chroma. Now, this is not something you'll notice too much if you're just getting started, but if you start looking at higher quality eyepieces and wide field of view eyepieces, you might this might become a consideration. So basically, chroma is an aberration in telescopes where the stars closer to the edge of the field of view look like little comets instead of sharp dots, and the effect is worse in wide field eyepieces usually, and it's worse closer to the edge. So if you look at this picture down here, the stars at the edge look like little comets instead of looking like sharp dots, which is what they really should look like. So this is a pretty common aberration, but it could be from your telescope or your eyepiece, so it could be either one really. The telescope that I was using for doing this comparison has a flat field. It doesn't have chroma visible because I'm using a chroma corrector. So even though it's a fast 800mm f3.9 focal ratio scope, I'm using a good Skywatcher Quadro chroma corrector, so it shouldn't show any chroma. So any chroma visible is from the eyepieces themselves. So that's the first aberration. The second thing that I tend to look at when comparing eyepieces is distortion. So distortion is basically unequal magnification across the field. So if you move a bright object like the moon away from the center towards the edge of the field of view, it might appear a little bit stretched. So it doesn't, in the second picture that you can see on the right here, the moon doesn't look perfectly circular, which is what it's supposed to look like. It looks like a bit of an oval because it's closer to the edge there. So that's distortion that you see in some eyepieces. The third thing I look at is longitudinal chromatic aberration. So this is regularly what we consider chromatic aberration. Is just purple fringing. So usually you would notice that in cheap refractor telescopes, so not apochromatic refractors. Usually most cheap department store telescopes will have that, or sometimes an eyepiece can as well if it's not well corrected. So you can see a purple halo around this bright star in this image, whereas in the last image you don't really see that. So that's a better, higher quality telescope. And you also rarely see this in Newtonian reflectors or Schmidt-Cassegrain telescopes. Usually you'd see chromatic aberration in refractor telescopes if they're not expensive refractor telescopes like apochromatic refractors. But this could also be from your eyepiece if it's not well corrected. Next, I look for lateral chromatic aberration. So this is basically dispersion of colors closer to the edge of the field of view. And I've found that this kind of aberration is usually present because of the eyepiece itself, not really the telescope. The stars near the edge appear purple or violet on one side and red on the other side, instead of being one uniform color, usually white or blue or orange. So this kind of aberration is usually not visible on deep sky objects. Is usually visible on bright objects like stars, the moon, or the planets. So you'll usually see this kind of aberration in wider field eyepieces that are not very well corrected, and it's going to be more pronounced towards the edge of the field of view of an eyepiece. And up next is field curvature. So if an eyepiece suffers from field curvature, the center and the center of the field of view and the edge usually won't be in focus at the same time. So you can either have the edge in focus, or you can have the center of the field of view in focus, but the stars in one or the other usually won't be in focus at the same time. But if your telescope has a flat field and your eyepieces are well corrected, then this one shouldn't be an issue. I don't see this kind of aberration very often. And lastly, astigmatism. So if your telescope or your eyepiece suffers from astigmatism, then your in-focus stars will look like little crosses instead of looking like sharp pinpoint dots. And when you focus in or out, the diffraction pattern that you get, the circular pattern, won't be perfectly circular. It will look like a bit of an oval. So sometimes this can be caused by imperfections in your telescope mirror, but it can also be caused by eyepieces that are not very well corrected. So if you have any particular questions about eyepieces or any particular eyepiece or astronomy in general, just post it in the comments below and I will be sure to answer. I'm usually quite good at getting to the comments. And for the images used in this slideshow, I got them online. There's no point in inventing the wheel, so, or a second time, I guess. So I just used the images that I found at these sources. So you can look them up if you want to find the original source of those images. So my methodology for comparing the eyepieces was fairly simple. This is what I did. I'm just going to switch over to Stellarium. There we go. So this is the object that I had used. This is Messier 44, the Beehive cluster in the constellation of Cancer. And I use this cluster because it's fairly large, fairly easy to see even from my backyard. And being so large, I could use a variety of eyepieces on it. I could use wide field eyepieces as well as shorter focal length eyepieces for a more zoomed in view. So what I'm going to be doing is I've entered all of my eyepieces into Stellarium. So it has this very handy feature. If you click on this wrench, you can add all sorts of eyepieces and telescopes in there. So I've added all of my eyepieces in there right here, as well as all of my telescopes. So this way I can quickly change between different eyepieces and see what field of view it gives me, as well as what magnification. So this is M44, the Beehive cluster. This is how it looks through my Lunt HDC 20mm 100 degree eyepiece using my Orion 8-inch f3.9 telescope, and this gives me a magnification of 40 times. So you can look for the magnification right over here. It also gives you the field of view. So in my case, that's a 2.5 degree field of view, which is very, very wide field. And so if you're looking for technical information on any of these eyepieces that I review, it's going to be right up here in the top right hand corner, and information about the object we're looking at will be at the top left hand corner. So basically that's my methodology. And the other thing I did was, besides using Messier 44, the Beehive cluster, I also looked at the double star Castor in Gemini, the twins. So I used that to gauge how good an eyepiece is at separating stars. Some of the stars appear as individual stars, but if you look at them through a telescope at higher magnification, you can see two distinct stars, or two or more distinct stars actually. And then after that, I looked at the moon as well, just to see how each of the eyepieces performs on the moon. So that's usually a good test of chromatic aberration or distortions. So that was basically my methodology, and it was fairly simple. And also on the Beehive cluster, one of the things I looked at was right near the center, right next to this red star, there's a fainter star. So I also used that to determine how well the eyepiece handles glare from the brighter stars. So in some of the eyepieces, I wasn't able to see the fainter star because there was some glare from the brighter star, and the eyepiece wasn't able to handle that very well. So that was one of the other tests I used to determine eyepiece quality. So we'll zoom back out, and now we can get started. So the first eyepiece we're going to look at is the HDC 20mm 100 degree field of view eyepiece. So here is the eyepiece itself. Now overall it seems like a very high quality build. You can see the nice large eye lens over there, full metal construction, soft rubber eye cup. It works quite well in the cold as well. That's the bottom lens group over here. The coatings all seem very nice, and yeah, it's a good grip. I have absolutely no issues with the construction. It's a heavy duty chunk of glass for sure. And this one only comes in a 2-inch barrel, so you will need a 2-inch focuser to use this in your telescope. That wouldn't be a problem for most Newtonian reflectors, most larger ones at least, but if you have a Schmidt-Cassegrain, an SCT, then generally you'd want to double check to make sure it has a 2-inch focuser, sorry, a 2-inch visual bag available, because a lot of them tend to come with a 1¼ inch. So I upgraded mine to a 2-inch as well, but mainly I'll be using this in my Newtonian reflector. So on M44, Messier 44, I'm gonna switch that in Stellarium. There we go. This is what it looked like. So M44, the beehive cluster, was easily framed fully in this eyepiece, and I got a magnification of 40 times and 100-degree field of view. So the true field of view was 2.5 degrees. And the view was sharp edge to edge. There was very little, if any, distortion visible, and the only minor distortion that I could see was in the outermost part of the field of view. It was not objectionable at all, and the entire cluster actually easily fit in the central 50% of the field of view with this eyepiece. So the fainter star near the red star in the center of the cluster was easily visible, so there was almost no light scatter. The view of the cluster overall was very, very nice and sharp, and the magnification was too low to actually split the double star Castor, which was my next test. And then I switched over to the moon, and the view on the moon was nice and sharp, and there was some minor distortion on the moon when the moon was near the edge of the field of view. So the moon doesn't seem perfectly round, but that's to be expected near the edge of the field of view of a 100-degree eyepiece. So that's pretty normal. And I could see some minor chromatic aberration near the edge and a yellow border around the very edge of the field of view when the moon was hitting the edge. That's not an issue in any other circumstance that I could see, so it doesn't take away from the view at all. So overall, absolutely excellent eyepiece, one of my favorites, and this is the one that stays as my wide field eyepiece in my 8-inch f3.9 reflector all the time, and it's also my primary visual eyepiece with my 16-inch f5 Dobsonian. So if you don't want to buy an expensive Ethos 21, this is a good alternative for a lot less than half the price of that eyepiece. Okay, so up next, our next eyepiece is this one over here. This is the William Optics XWA 101-degree 9mm. And looking in Stellarium, this eyepiece right over here. So this eyepiece gives me a true field of about just a little bit over 1 degree. So this is my primary medium field eyepiece, and the cluster is pretty nicely framed in this eyepiece. It has a nice 100-degree field of view, so the cluster itself, it's almost fit. The overall view was very, very nice and sharp, and the faint star near the center was easily visible, and the view was sharp almost all the way to the edge. There was maybe some very minor coma in the outermost 5%, but it was not really anything that was noticeable, and there was no light scatter, astigmatism, or any other aberrations that I could see. And this is one of my favorite medium field of view eyepieces, and if you could only have one medium magnification eyepiece, I would recommend this one. And it is a lot cheaper than the Ethos series, but it gives you excellent performance. Now I found that the eye relief on this eyepiece was actually quite good. I noticed that there were some complaints from people online that that they couldn't look through this eyepiece. They couldn't see the entire field of view while looking through the eyepiece because the top is quite flat, so you need to get your eye closer to it. That was absolutely not a problem for me, and I don't wear eyeglasses, so I can see the entire field of view in one go without having to get too close to it. But if you do wear eyeglasses, you might have to remove your eyeglasses to see the entire field of view. And using this eyepiece, the moon was very nice and sharp. There was no distortion, but I did notice a tiny bit of chromatic aberration in the outer 30% of the field of view, and it showed purple on one side and yellow on the other side. But again, it was very minor. And there was a minor purple halo around the very edge of the field stop when the moon hit the field stop, but it wasn't visible in any other situation. So again, it doesn't take away from the view at all. And this is probably my favorite medium power eyepiece. And again, just like the 20mm Lunt, it is a heavy-duty metal construction, so fully made of metal. The only things that are plastic here are the nice grip over here, as well as the rubber eye cup, and that's about it. Those are the only things that are made of plastic. And this eyepiece, plastic or rubber. So this eyepiece, it is a 2-inch barrel, but you can unscrew the bottom part, and right over there now you've got a 1 1/4 inch barrel, so you can use this one in 2-inch or 1 1/4 inch focuser, so it'll work with any telescope out there. But it is a fairly heavy eyepiece, so you probably don't want to use it on a very, very small scope, but any decent high quality scope it would be perfectly fine with. So if you have an 8-inch Dobsonian telescope, it would work great with that, so no issues whatsoever with that. And again, with this eyepiece, the double star caster was easily split, and the view was very, very nice and clean. It was a clean separation. So the next eyepiece that we're looking at is this guy over here. This is the William Optics XWA 5mm 110-degree eyepiece. So this is again full metal construction, just like the previous two eyepieces that we looked at, the one from Lunt Engineering and the William Optics 9mm. So fully metal, and it works in a 2-inch barrel as well as a 1 1/4 inch barrel. You can just unscrew the 2-inch barrel over here and it will work in any telescope. And the only things that are again plastic or rubber is the eye cup over here and the grip. So absolutely no complaints about the build quality. Very, very nicely done. And I also happen to own the Lunt Engineering version of this eyepiece. So this is the HDC 5mm 110-degree eyepiece. Optically, they're the exact same eyepiece. The only difference I notice is is entirely cosmetic. So everything else looks the same, just that the Lunt Engineering eyepiece is a little bit thinner and lighter, and it has this regular soft eye cup versus the William Optics one, which has a flat top. So there were some complaints online from some people who weren't able to see the entire field of view as easily in the William Optics one compared to the Lunt one, so that's why I decided to buy both and compare them directly. What I found after using them both fairly extensively was that personally for me, I had no issue seeing the entire field of view in the William Optics version, but probably because my eyes are a little bit further apart and I have a fairly big head, I'm told. So I was able to see the entire field of view easily, so that wasn't a problem. But if you have a fairly small head or your eyes are closer together and you know, your nose hits the eyepiece or something like that, then the Lunt Engineering one might be better for you. But I found it easier to look through the William Optics version despite the flat top. So I'm going to keep this one, and I think I might end up selling the Lunt Engineering 5mm because I don't need two of the same eyepieces if they're optically the exact same. So that was my experience with them in terms of use. Now optically, if you're wondering how this one fares, well, just like the other two that we looked at previously, optically it's very, very good. The view is nice and sharp in the center and pretty much all the way to the edge as well. The faint star in Messier 44 that I was looking at near that bright red star was easily visible, so there's no light scatter. And there might be some minor coma in the outer 10% of the field of view and perhaps some minor astigmatism, but not really anything that's noticeable even in the outer 10% of the field of view. I noticed some minor lateral chromatic aberration in the outer 10 to 15% of the field of view, but it was not distracting as the view was still very sharp near the edge. And if you only have one high magnification eyepiece, I would recommend this one. And again, it is cheaper than the Ethos series. And if we look at Stellarium to see what the field of view of this eyepiece looks like, that's what it looks like. So very, very zoomed in. So to give you some context, that was in the 20mm, 9mm, and 4.7mm. So in the 4.7mm, this one would give you 170 times magnification in my telescope and about a half degree field of view. And the apparent field of view in this eyepiece is 110 degrees. And even though it says 5mm, this is actually a 4.7mm focal length eyepiece. So if you're trying to figure out the magnification it'll give you in your telescope, basically divide your focal length by 4.7 instead of 5, and that'll give you the actual exact magnification for this eyepiece. So we'll switch back here. Okay, and again, the double star caster was an easy split at this magnification. It was very nice and clean separation, so no issue there. The moon looked nice and sharp and it filled the entire field of view with this eyepiece. I didn't notice any distortions, and the moon looked circular even at the very edge of the field of view. I noticed some very minor chromatic aberration near the edge of the 110 degree field, and there was a minor purple ring visible around the very edge of the field stop of the eyepiece when the moon hits the field stop. But again, that's not visible in any other situation, and it was about the same amount of let's say purple ring visible as the 9mm eyepiece that we looked at previously. But again, it doesn't take away from the view at all, and it's not visible in any other situation. So overall, for a high magnification eyepiece, this is my go-to high magnification eyepiece. And just the combination of very good correction, very, very wide field of view, and overall sharpness make this my favorite high magnification eyepiece. The only downside is that, again, it is fairly heavy. So if you have a very light or small scope, it might be a bit too big for that. But again, works in both 2-inch and 1 1/4 inch barrel eyepiece holders, so it should work with any telescope. So up next, we'll be looking at the Orion Stratus 24mm 68 degree field of view eyepiece. Now this eyepiece is actually the same as the Celestron Ultima Duo or the Baudelaire Hyperion, both in terms of optics as well as just the general construction and look and feel of it. I believe the Baudelaire Hyperion do use a different kind of coating, so that might affect the color of the view that you see, but overall they're very, very similar. I've owned well, obviously the Orion Stratus eyepieces, the Baudelaire Hyperion eyepieces, and the Celestron Ultima Duo eyepieces, and I found them to be practically the same. I really couldn't tell any difference, and I'm not sure how much of a difference the coatings make. So overall, they should be fairly similar. Now, just like the Baudelaire Hyperion eyepieces, the Orion Stratus line comes in both the 2-inch and the 1 1/4 inch barrel. So right over here is where the 2-inch barrel stops, so you can put it into any 2-inch eyepiece holder as well as a 1 1/4 inch eyepiece holder. So that's a really good feature that I liked of these. And the construction feels very solid, so no issue about that. It's pretty easy to grip because of the rubber over here. I didn't have any complaints about the soft rubber eye cups, so mechanically they're quite good. And the view I found was it was fairly sharp in the central 50%, and then it began to degrade after that. And if we switch over to Stellarium over here, you can see that in this eyepiece the entire cluster Messier 44 easily fit within the field of view, but despite this being a 24mm eyepiece, which is wider than the 20mm we looked at first. The field of view is only 68 degrees, so the field of view does feel a little bit more restrictive compared to the 20mm 100-degree eyepiece, which was the first one we looked at right here. For example, you can see that the field of view is much larger on that 100-degree compared to the 68-degree here. But if you're not comparing them directly, then you know, it's not as big of an issue. But I did notice that the faint star near the center of Messier 44, it was visible, but there was a minor amount of flaring on the brighter stars nearby, and the view was pretty sharp in the central 50%, but then it began to degrade after that. And the outer 30% of the field of view in the Orion Stratus eyepiece, the 24mm, it was not very good at all, and I would not recommend this eyepiece as a primary wide field eyepiece for anybody. Now the moon looked pretty nice and sharp in the center, but as I moved the moon towards the edge, I started to notice some distortions, about 50% of the way to the edge, meaning that the moon was no longer circular, about halfway to the edge of the field of view, and it began to lose detail. And in the last 20%, I couldn't see any detail in the craters anymore. And I also saw some purple fringing close to the edge as well, but it was fairly minor. And when the moon was hitting the edge of the field of view, or the field stop, I could see some minor yellow, I could see a minor yellow border around the edge, but it wasn't too distracting. So overall, it's a decent eyepiece. It was an upgrade from the very basic Plossls that come with a lot of telescopes, because it does give you a wider field of view and much better construction. And you can use it in both a 2-inch and 1 1/4 inch eyepiece holder. But again, I just found I would not use this as my primary eyepiece for wide field viewing. The performance in the outer parts of the field of view is just not very good. And up next, we will look at the Orion Stratus 13mm 68-degree field of view eyepiece. So again, this is the same as the Baudelaire Hyperion and the Celestron Ultima duos. You get a nice large eye lens over here, which makes it pretty easy to look through. I haven't noticed any kidney beaning or blackouts or any other issues like that. The construction is good. Will work in both a 2-inch and a 1 1/4 inch barrel eyepiece holder. If we switch over to Stellarium, we can see what it looks like. There we go. So the cluster is a bit more zoomed in, fits most of the cluster. With my telescope, gives you a magnification of 61 times, whereas the 24mm gave a 33 times magnification. So at 61 times, it gives me a field of view of just over 1 degree, which is pretty good. So it's not exactly a very wide field eyepiece, but I'd consider it a decent medium field eyepiece. Now, in terms of optical quality, when looking at Messier 44, the beehive cluster, I found that the view was pretty sharp in the center, and the faint star near the red star in the center of the cluster was visible. And I started to notice coma in the outer 50% of the field of view, and the outer 30% of the field of view was pretty much useless. So I would not recommend this as a primary medium magnification eyepiece. Then I switched over to the moon, and the moon looked fairly nice and sharp in the center, but as I moved the moon out towards the edge, I started to notice a minor chromatic aberration about 50% of the way to the edge of the field of view, meaning that the moon was no longer circular, about halfway out from the center of the field of view, and it started to lose detail. And in the last 30%, I couldn't see any detail in the craters. And I also saw some purple fringing closer to the edge as well, but it was fairly minor. And when the moon was hitting the edge of the field of view, or the field stop, I could see a very minor blue or teal ring around the edge, but it wasn't distracting, as it was barely noticeable. So overall, it would be an upgrade from the very basic Plossl eyepieces, but for the price, I would probably skip this and go with one of the other eyepieces that we'll discuss in this review. So again, better than the cheap Plossls that you get with scopes, but not my favorite line of eyepieces. I would recommend avoiding these ones, and the 13mm is no exception to that. So that was my look at the first 5 eyepieces in this review, and first 6 actually, if you count the Lunt Engineering HDC 5mm, but basically since that is the same as the William Optics 5mm, well, we'll just count that as one eyepiece. So that was the first 5 eyepieces I was going to look at for this review, and to see the next 5, check out the next video in this series. That's part 2 of 3. So I'll see you there.